Okay, this is Mr. Bullens with a review for our upcoming test on air pressure, winds, and weather. Right now, what I want you to do is take out a sheet of paper, and it's time for your brain dump. Now, a brain dump is what you do. You think about what's going to be on your test. Now, we know things like air pressure, winds, weather. That might be sea breezes and land breezes. We're going to talk about high pressures and low pressures. We're going to talk about the different types of weather you might have on the equator and the mid-latitudes. We're going to talk about the prevailing westerlies. We're going to talk about how air blows. We're going to talk about how wind is formed. We're going to talk about being able to accurately forecast weather based on high pressures and low pressures. We're going to talk about how weather moves across the United States. We're going to talk about the jet stream. And those are the things that we're going to use for our memory dump. So I want you to take a few minutes to write this stuff down. And when you're done, move on to the next portion of this. I'll give you a moment to pause. Okay, we're back. And let's talk about what we know. Winds. Using our notes, we know that wind is caused by differences in air pressure. We talked about this in the classroom when we had a balloon. And we blew the balloon up, and we said on the inside of the balloon is very high pressure. On the outside of the balloon is low pressure. And we all know that if you let the end of the balloon go, the air is going to come out of the balloon, moving from that high pressure area to that low pressure area. And that's something that we need to think about with winds. One of the things that causes wind is the unequal heating of the Earth's surface, or as I have written here, the unequal heating of the land. And that causes differences in air pressure. That hot air is rising, that cold air sinking, those convection cells that we talked about. And again, when the air is going to move from high pressure areas to low pressure areas. There are types of winds that we looked at, and there's one extremely important one. It's going to be this first one right here. It is the prevailing westerlies. They're called the westerlies because they blow from the west to the east. You need to know that. This is important because that's what moves weather across the United States, and it's what moves weather across North Carolina. You will see that again. We talked about how these winds curve due to the Coriolis Effect, and we'll talk about that right here in our notes. Here's our Earth, and we said that up here, in the upper parts of the Earth, at the poles, we had kind of cold air. And we all know that in the next latitude there, the mid-latitude, just going to put them about right here, we have warmer air, not hot air by any means, but we know that that warm air is going to move up towards that cold, and it's going to move up and it's going to curve. Now you'll notice this is moving up and curving in a west to east motion. That's moving up towards that cold because hot rises. Now the cold air in the poles is going to sink, and it's going to move from the east to the west. Now the curvature of these winds is due to the Coriolis Effect. Now the Coriolis Effect is something that I'm not too sure that you'll see on the test, but it's something I need you to remember. We talked about that's why the winds curve. Now just below all of this, we have some other areas. Don't forget, in the middle here we have the equator, and this is where it is the hottest, the most, because the sun focuses here the most. Not a lot of winds there. That's the doldrums. The horse latitudes will not be on there. Just your polar easterlies and your prevailing westerlies. Trade winds, possible that you could see those, but I don't recall seeing those on the test, and we covered that enough in the classroom. Now, when I'm also thinking of wind, one of the first things that comes to my mind is sea breeze and land breeze. Now, it's daytime. Again, picture yourself at the beach, walking across that sand. You know it's hot. And that hot air above the sand is going to rise. And that is a very low pressure because there's not a lot of air. All the air is going up. Well, we know above the ocean where it is cooler, we know that cool air sinks. That's a higher pressure area. That higher pressure is wanting to sink in to over here to where the pressure is low. It's just something to think about when you're thinking about that. And that constant circulation, that convection cell. When you're at the beach and it's hot, the wind is blowing from the ocean to you. Now, this is something to think about. I might be at the beach, and it's a very nice day because I feel that breeze. That is a terrible breeze. Sorry about that. But I feel the breeze blowing on me. And it's really nice to sit on the beach and have that breeze hit you. If you were to leave the beach and go maybe a mile inland where it's still super hot, but you don't have that convection cell, it's going to be a lot hotter. It's still at the coast, but it's a lot hotter. So let's think about what happens at night. Typically, when you go back to the beach at night and you walk on this sand, it's really cool because the land cools off quickly. Well, now your cold is over here, and it's sinking. Your water has spent all day staying warm, and the air above it is rising. Now we have the opposite going on. My wind is now moving, I have to do the wind in yellow, is now moving from the land to the sea. And we call that a land breeze. So we have our sea breeze, and we have our land breeze. So it's a sea breeze and a land breeze. Now let's move on. Here we're going to take a look at the jet stream. Now the jet stream is what they may sometimes call a river of air. I've seen it described as that very often. Now what a jet stream is it is a river of air. And what it does is it separates cold air mass and a hot, well, it's called a warm, always hot, a warm air mass. And you can see that here. Up here in the north, cooler. Down here, warmer. And that's what a jet stream does. And the jet stream is moving fairly quickly, but the greater the difference in the cold and the warm here, the faster the jet stream blows. Now, we've all seen this. And when students think back to maybe a few years ago when we couldn't even come to school because it was too cold, the buses wouldn't even start. That's when the jet stream dipped south of North Carolina. Here we are. We are above the jet stream at that point. The jet stream is down below us. And what that happens is it sucks in all of that cold air down into this area. And that's when we get those super cold bursts during the winter. And that's important to think about because when the jet stream dips down low like that, you're going to experience colder weather. Now let's think a little bit about what we talked about with high pressure and with low pressure. And there's an easy way that I remember this, high and low. Now, the common mistake is to call this hot. That is not necessarily true. High pressure systems, they bring, so high pressure brings happy weather. Notice that the one starts with an H and the other starts with an H. High and happy. Happy weather, that means it's clear skies, clear skies, sunny. It might be a little cool. I know that sounds weird. That's an H, but it's a high pressure system. Now our low pressure system, again, be very careful with this. It's a very common mistake for students to make, and I do not want you to make it. A low pressure system is not going to bring low temperatures. It's going to bring storms. This brings, and watch this, L, lousy weather. In the wintertime, when you have a low pressure system, you could have snow or sleet. I remember it with this. Lousy starts with an L, low pressure starts with an L. Happy starts with an H, high starts with an H. And that's the way I differentiate those two. And what you'll notice on here is this really just kind of confirms that. Around these low pressure areas, what do you see? Storms. Around the high pressure areas, no, it's clear. Look at that. No clouds showing up. Low pressure area, storms. High pressure area, clear skies, and happy. We need to think about all of the different aspects of the globe, and we know that in the poles up here it is cold, and it stays cold pretty much year round. Here at the equator and even above in the tropics, it stays hot pretty much year round. Now for us, we live in this mid-latitudes. What you're going to notice here, I'm not even going to try to write that out, I'm going to just do this, is you're going to notice that in the mid-latitudes, changes in weather. For us, especially here in North Carolina, we have 4 seasons. You're going to need to know that. Those are very important aspects of the globe that we've talked about. It has to do with the jet stream. It has to do with comparing and contrasting the equator to the mid-latitudes, knowing that one is hot all the time and one has a change in season. It's just important that you go back and remember those notes that we took on the globe, and then the polar easterlies, the prevailing westerlies, we have the trade winds, the doldrums, and then the same set that goes down this way, and that's all in your notes that you have, and that's extremely important to remember. Now that we have, now that we have set up our memory dump, I mean, think about this. We've gone about, 12 minutes without even thinking about looking at questions on a test. That's the way you should do it. Put all of your stuff down on paper that you know beforehand. If you're like me, you get super nervous when you're taking a test. And sometimes you forget things that you honestly and truly know. And I want you to be able to remember that. So do the memory dump, the brain dump first. Then take a look at the test. I'm going to stop this video and we're going to bring up a second video that I'll give you a link to that will take us to reviewing the test.